this is chapter 0, section 4. This is kind of just a hodgepodge of review from Algebra 1. But the first thing I want to start off with really quick is, I mentioned this the other day, but this is the type of formula, or the type of question where there's two separate ways to do it. Using slope-intercept form is the way I was told that you guys were taught in Algebra 1. I've showed you how to use point-slope form, but I've never showed these two side by side. I don't necessarily care which way you do it, whichever way you think is easier. And once I do this, I'll kind of tell you the pros and cons of both of them. So let's start with the other way that you guys learned last year. So using slope-intercept form, we're obviously starting with y is equal to my mx plus b. And the question is, the equation of a line in slope-intercept form, or write the equation of a line in slope-intercept form that has a slope of 1/2 and goes to the point 4,3. Now with this, it's important to realize that first off, we know the slope, but we don't know the y-intercept. So we're really trying to find the y-intercept with this. Once we know that, then we are golden. We can write it in slope-intercept form. But since we don't know that, we have to use this ordered pair, and we know that that is an x and y. So we plug this into our equation first. So we plug in the x and the y. So my y is 3, so I have 3 is equal to, my slope is 1/2, times my x is 4, and then we don't know what b is. That's what we're trying to solve. So from here you can solve 1/2 times 4 isn't too bad, but again, you can use a calculator. You have fractions, that fraction button on your calculator. 1/2 times 4 is 2. Subtract 2 from both sides. 3 minus 2 is 1, so we got our y-intercept is 1. So that is not your answer, and that's one of the reasons I don't like this very well, and a lot of students miss this because they get b's equal to 1 and they think they're done. You still have to go back and put it in slope-intercept form. So that is the y is equal to mx plus b. But this time you don't put the x and y in. We leave the y. We know the slope is 1/2. We leave the x. We don't sub in this ordered pair for this part. Plus 1. So that is your answer. Now, real quick, the reasons I don't really like this one is, like I said, you get b's equal to 1, so a lot of students forget and they think that's their answer, so they stop. And then a lot of students get confused and they still plug in the 4 and the 3 for this x and y. So if you can remember not to do that, totally use this method, that's fine. Sometimes this is quicker than the other one. And again, if you did an Algebra 1, maybe you guys are better at that one, and that is, again, completely fine with me. So I've been using point slope form. That's the y minus y1 is equal to my slope times x minus x1. So I sub in my x and y. So my y is 3. My slope is 1/2. X minus my x value is 4. And again, we do this the same way we've been doing it. The last couple days we've had some like this. I take my 2 and distribute that to the left. My 1, distribute that to the right. So I have 2y minus 6 is equal to 1x minus 4. And then we go ahead and solve for y. So add 6 to both sides. 2y is equal to x plus 2. Then divide everything by 2. And you end up getting y is equal to, x over 2 is the same thing as 1 over 2x. And then 2 divided by 2 is 1. So as you can see, we get the exact same answer. It all depends. Sometimes it does take a little bit longer to do point slope form. Sometimes it goes a little bit quicker. It all kind of depends. And it all depends on if you get some messy fractions. So if you have point slope form, it's kind of nice because your messy fractions are until the very last step, whereas this one, sometimes you have to deal with these fractions in the middle. But for the most part, if your y-intercept is an integer, is a normal number, then it doesn't matter really which one you use. If your y-intercept is a weird decimal or a fraction, then point slope form is definitely the way to go. But I don't think deal with very many ones that have the y-intercept being a fraction. So I originally planned for this one to be one that doesn't work as well using the first method, but really, again, it comes down to using fractions. So if you do this using the other way, we have y is equal to mx plus b. So my y is 13, my m is 4 over 3, my x is 9 plus b. Now again, I was trying to get one that made this fraction a little bit more messy, but really you guys could probably do this fraction pretty easily. 4 over 3 divided by 9, um, depending on how you reduce it and how you look at that fraction. But that ends up being 12, I believe. And so this one really isn't that bad. I was trying to think of one that was more confusing, but I think as long as your y-intercept, like I said, as long as that's a normal number, an integer, then I think this method really isn't too bad, especially because you can use calculators with fractions. But either way is fine. Like I said, whatever you're comfortable with is completely fine with me. So let's start getting into some of these other ones. So we're starting off with some of these special cases. We're solving these for x. So the first one, we divide both sides by 4. 0 divided by 4 is just 0. So x is equal to 0. Not really a special case. It's a little bit unique. It doesn't happen a lot, but x is equal to 0 is completely fine. This next one, if we subtract the 4x from both sides, we end up getting, so it cancels here, but over on the right-hand side, 4x minus 4x also cancels. So all we're left with is 8 is equal to 12. So if all of your x's cancel, you have two different options. It's either all real numbers, you can't really read that, or no solution. So it's one of those. If all your x's cancel and all you're left with is a number, and the way you decide which one is look what you have as your answer and tell me, is that true or false? Is 8 equal to 12? Not at all. 8 is not equal to 12. So this one's no solution. It's not all real numbers. As you can assume, this next one, subtract 4x from both sides. This one, they both cancel again, and you end up with 8 is equal to 8. That is true. 8 is indeed equal to 8, and so it is all real numbers. So just real quick, if you ended up have 4x is equal to 0, that ended up giving x is equal to 0. That's one solution. Sometimes they ask that. How many solutions? 0 is equal to 4, so something that's not true. And this one is referring to this equation here. If you would subtract 8 from both sides, you would end up with 0 is equal to 4, but that's no solution. And then 0 is equal to 0. That'd be if you subtracted 8. Up here, if I subtracted 8 from both sides, you get 0 is equal to 0. Is all real numbers. Whoops. All real numbers. Or infinitely many solutions. There should be an I in there. Many solutions. Also, you can abbreviate that to infinitely many solutions. All real numbers is a little bit shorter to write, so that's what I would put. So really the big deal is if you get all your x's to cancel, you should know it's one of those options. It's either no solution or all real numbers. Then moving on to graphs, draw a diagram of the quadrants and then graph and label each point and decide which quadrants it's in. So this is when you're going to have to be a little bit careful when you draw this. And I make my graphs nice and big because I think it's harder to make them small. So we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. I will, on tests and quizzes, I will always give you a graph because it's really hard to read some of you guys' graphs, and mine including. So this is the graph. That's what they're saying where they say draw a diagram. The quadrants are, this is quadrant 1, this is quadrant 2, this is quadrant 3. Whoops. Can't really read that very well. This is quadrant 4. So you just have to memorize that. It is counterclockwise, 1, 2, 3, 4, and then you just have to say where each one is at. So A is 3, 2, so we go over 1, 2, 3, and then down 2, so that's down here. So that's in quadrant 4. They kind of put them in Roman numerals, but if you just put 4, I can live with that. I'm not going to be super finicky about that. I don't know if they were last year, but I'm not going to do that this year. B is, that was A, I should label. B is negative 1, 5, so back 1, up 5, 1, 2, 3, 4, 5. So that's in quadrant 2. And the last one, 0, 4, we go over 0, up 4, 1, 2, 3, 4. And that is right on the axis, and so that is none. That's not in any quadrant because it's right on the axis. So you could put none. That'd be the best answer. If you want to be a little bit more specific, you could say it's on the y-axis. But I would just put none. I think that's the easiest. All right, we did a little bit of this with functions in the last class, and the last lesson we did. And this is where I was specifying that the reason they put f of x and g of x is so you can tell which one you're plugging things into. So f of 4 tells me I'm plugging 4 into this f equation. So we have 4 squared minus 5, hold on, let's use parentheses, times 4 plus 1. Anytime I plug numbers in, I always use parentheses. It's a pretty good habit to get into, and it is very helpful for a lot of problems. So 4 squared is 16. 4 times 5 is 20 plus 1. 16 minus 20 plus 1 is negative 4 plus 1 is negative 3, I believe. So again, the best way to write this is f of 4 is equal to negative 3. Now, honestly, you can plug this whole top row into your calculator and get your answer. If you do that, I would just very much caution you to be careful. I think it's way better to put 4 squared in your calculator first, and then negative 5 times 4 in your calculator, and then once you get to this step, then you can put all of it in your calculator. But I like to show those steps. Again, that's another one of those things that if you show all your steps and you take your time to do that, it makes you miss a lot less small points on there. So the next one is g of negative 3. So now it's saying we're using our g equation. So we plug this in. So we have 5 minus 2 times negative 3, and that's especially good to use parentheses. Negative 2 times 3 is positive 6, so 5 plus 6 is 11. So g of negative 3 is 11. So again, I wouldn't put this in my calculator all in one step. I think it's kind of hard to stay organized that way, but it is also a good idea. I do it a lot of times when I check my work. So type in 5 minus 2 times negative 3 in parentheses, just to make sure you get that answer. And the last one, we did this before, but it's saying g, a plus 4. So I go to my g equation and I plug in a plus 4. So instead of 5 minus 2 times x, we don't have that x, we are plugging in a plus 4, and then we just simplify. So distribute that to the negative 2, negative 2a minus 8. Combine your like terms, negative 3 minus 2a. Okay, going on to systems of equations. Hopefully, this is one of those things that's a little bit more difficult in Algebra 1, but hopefully you have a little bit of a handle on it. But if not, that's okay. That's why we're getting this review. So substitution elimination are what we're going to use mostly. You can also use graphing, but that takes a little bit longer, and you have to have graph paper or really good handwriting, and so I usually use substitution elimination. So I use elimination if they're both in standard form. So the x's are lined up, the y's are lined up, the answers are lined up, but also the equal sign. Sometimes they trick you with that. So we want to add these equations together and get either our x or our y to cancel. If they don't cancel, we need to multiply them by something. So this first one's actually one where I have to multiply the numerator and the denominator by something. And so there's a couple different ways to do this. I'm going to get rid of my y's. And literally the only reason is because one's positive and one's negative, whereas the x's are both positive. So if you want to cancel your x's, you definitely can. I'm going to go ahead and cancel my y's. So I'm going to multiply the top equation by 4, multiply this bottom equation by 3, and then again, I know some students try to take shortcuts with this. I rewrite the whole equation. So 4 times 2 is 8x, 4 times negative 3 is negative 12y, 4 times negative 7 is negative 28. Then my next equation, 3 times 3 is 9, 3 times 4 is 12, 3 times 15 is 45, I believe. Yes. And now we can add these together. So negative 12 plus 12 cancel. That's the whole reason we did that. That's the whole idea. 8 plus 9 is 17x. Negative 28 plus 45 is positive 17. So divide everything by 17. We end up getting x is equal to 1. So that's super nice, but that's not our answer. We have to plug that one back in and solve for y. So it doesn't matter which one you plug it into, first equation or second equation. I'm going to plug it into my second equation because, again, there's more positives, but either one works. So we have 3 times 1 plus 4y is equal to 15. That's 3 plus 4y is equal to 15. Subtract 3 from both sides. I'm running out of room here. 12 divided by 4. Y is equal to 3. So last but not least, your answer is an ordered pair. X is 1, Y is 3. Again, you can go back and check the answer. It's got to work for both of them, not just one of them. So I know that's kind of it's a little bit messy right now, but that's okay. And some of them are easier than that, where you don't have to multiply both equations by something. Sometimes you just have to multiply one of the equations. That's what number 11 kind of looks like. From here, the second one, this one I'm going to use elimination. And again, the giveaway with this one for me is that the x is all by itself here. And so I'm going to take the whole thing. If x is equal to y plus 8, that means I can sub it in for this x. So we have 4 times. I sub it in for that x, so I have y plus 8. Don't forget the plus 2y. A lot of people forget that when they substitute. So then from here we just distribute. 4y plus 32 plus 2y is equal to 2. Combine your like terms. 6y plus 32 is equal to 2. Subtract 32. 6y is equal to 30. Running out of space, so my y is equal to 5. And then it ends the exact same way we did the last one. Take that 5 and plug it back in. The good news with this is when you plug it back in, if you use the first one, or sorry, the equation that you had x all by itself, that's actually a lot easier. So x is equal to 5 plus 8, so x is equal to 13. So my ordered pair is 13, 5 for this one. Get some room for this next one. And again, you could have subbed it in that 5 that I just erased. You could have subbed that into the first equation. It would have worked fine. It's just a little bit easier using that second one. Number 10, again, the y is all by itself, so that's kind of nice to sub in. So I'm going to use substitution. If you wanted to use elimination, you could. You just have to put them both in standard form. There's some other ways to do it, but that's going to be the easiest way. So distribute that negative 2. That's negative 6x minus 4. 6x and 6x cancel, so we're left with negative 4 is equal to negative 4. So just like we had earlier, that means the answer is all real numbers. So again, anytime all your x's or all your y's cancel and all you're left with just a couple numbers, then just see if it's true or false. And this one was true. Negative 4 is equal to negative 4. So let's see with this next one. Maybe it's going to be the opposite of that. So from here, I'm going to use, they're both in standard form, so I'm going to use elimination. So if you cancel out your, I'm going to cancel my y's because all I have to do is multiply the top equation by 3. So 3 times 4 is 12x, 3 times y is 3y, 3 times 2 is 6. Now again, this is where a lot of students then don't rewrite the second equation because we didn't multiply by anything, but I think it's a really good idea to go ahead and rewrite it just to make sure we have everything nice and clean everywhere where we want it. Oh, sorry, it's negative 12. If you write it down correctly, which you should. So my y's canceled like I wanted to, but now my x is also canceled. So on the left-hand side, I don't have anything left. Everything canceled. On the left-hand side, I don't know if I said right. On the other side, 6 and 7 is 13. So this is false. So this is no solution. No matter what numbers you would plug in, you will not get a solution for that. Oops. And this last one, the last part is graphing lines, and it should go fairly quickly. So when the line is given to you in slope-intercept form, graph the y-intercept and then use the slope from the y-intercept to get the other points. And so this is the one where you know you're using your rise over your run. So your slope is a fraction, and so it's rise over run. One thing I've done in my notes before is the numerator I put as an arrow like this, and I put plus on top and minus on bottom. So in the numerator, it goes up and down. If it's positive, it goes up. If it's negative, it goes down. And then in the denominator, I do kind of the same thing left and right. If it's positive, it goes to the right. If it's negative, it goes to the left. That's the same thing as a rise over run, just a little bit more detailed. If it's in standard form, graph the x and y intercepts by using that eye patch method we've talked about. And then connect those 2 points. And then the special lines. If you get x is equal to a number, that is a vertical line, so it's straight up and down. And the slope is undefined. And again, that is a line that is straight up and down. If y is equal to number, that's the opposite. That is a horizontal line. So that's just going left and right. And that is a zero slope. So again, you're just going to have to commit that to memory. There's a couple different ways I've remembered this. I know horizontal has an O in it, so that's why it's a zero slope. I know I've had some people use the analogy of if you are a person and you're walking along the street, if you're not going anywhere, it's certainly flat. It is zero slope, but if it's straight up and down, you can't walk on it, and so you would fall and you would be undefined. If that helps you remember, that's great. If not, again, you're just going to have to kind of commit it to your memory. So slope-intercept form shouldn't be too bad. Your y-intercept should be 3, so always start with your y-intercept. And from there to your slope, it's 2 over 1, so we go up 2 over 1. I like to do a couple of them, up 2 over 1. Now remember, if you're going up 2 over 1 to the right, that's actually the same thing as going down 2 and over 1 to the left. So you can go down 2 over 1 the other way. You don't have to, but it's always kind of good to talk about that. Next one, your y-intercept is -4, so down 1, 2, 3, 4. Then we go up 1 over 3, up 1 over 3. And again, you go down 1 over 3 to the left. Now, I know some teachers that make you use like a ruler or an ID to make it perfectly straight. For me, I just make sure it goes all the way across my whole graph, and I make sure I put points on there that I can actually check. Same thing with these arrows. I'm going to try to put these arrows, but as long as you go across your whole graph, I'm not super nitpicky on that. Number 14, there is no y-intercept, so the y-intercept is 0. So that's one that a lot of people miss, but it's actually pretty easy. And then again, I put the negative with the numerator, so I go down 2, and then I go over to the right, 1, 2, 3, 4, 5. And then that is your graph. The eye patch method, since these are in standard form, cover up your x, y is equal to 3, so that's your y-intercept. Then do the opposite, cover up your y. So x is equal to 3, that's your x-intercept. Then just connect those. Now you could also put them in slope-intercept form. You could have subtracted the x from both sides on this one. So y is equal to -x plus 3 would have been the exact same thing. So whatever way you want to do it is fine. This one, if you cover up your x, we get divide by -1, so we get -8. 1, 2, 3, 4, 5, 6, 7, 8 is your y-intercept. And if you cover up your y, divide by 2, we get 4 for my x-intercept. So 1, 2, 3, 4. Just connect those. So this is where we have the horizontal and vertical lines. So y is equal to is a horizontal line. And again, the way I remember this is there is no slope, but your y-intercept is 4. So 1, 2, 3, 4. And then it's just a horizontal line. X is -3. 1, 2, 3. Straight vertical line. And x is equal to y. So again, this isn't slope-intercept form. The y-intercept is 0, and the slope, it's just x, so it's just 1. So you go up 1 over 1, up 1 over 1. And this one, you can memorize it's just a perfect diagonal where it's corner to corner, up 1 over 1, up 2 over 1, or 1, 1, 2, 2, 3, 3 are those ordered pairs. Then last but not least, we have some of these some inequalities. So the big thing is you graph these just like normal. So the y-intercept is 5, 1, 2, 3, 4, 5. Slope is 3, so up 3 over 1. Again, I like to do that a couple times. But again, I ran out of room, so instead of going up 1 over 3, I'm going to go down 1 over 3 to the left. So down 1 over 1, 2. Oh, sorry. Just made a mistake there. It's not 1 over 3. It's 3 over 1. And so I go down 3 over 1 to the left. So down 1, 2, 3 over 1. Down 1, 2, 3 over 1. Once you have this, then since there's no line under it, it is a dotted line. So don't forget that. If you ever mess that up, you can always just label it as dotted. Is fine. Then from here, you have to shade above or below that line. Those are your only options, no matter how you want to look at it. That's how I'm going to tell you to look at it, above or below, and you always look at your inequality. Since y is less than, that means you shade below. So all these ordered pairs I'm shading would make this a true statement. Same thing with this, but again, honestly, I usually put it in slope-intercept form, but if you want to use the cover-up method, you can. I just think it's a little bit harder to see which way to shade. So if you use the cover-up method, your x-intercept is -6. 1, 2, 3, 4, 5, 6. Your y-intercept is +2. It is a solid line, since that inequality has a line under it, the equal to line with it. But again, for me, it's hard to figure out where to shade this one. And so I think it's just easier to go ahead and put this in slope-intercept form. And I know it takes a little bit of time, but if you subtract x from both sides, you get -3y greater than or equal to -x minus 6. Divide everything by -3. But since we divide by negative, you have to flip your sign. So we have 1 over 3x plus 2. So that is what we have with the slope. And now it's very clear to see y is less than or equal to, so we shade below that one. So, sorry that was a little bit of a longer lesson, but we kind of have to get a lot in there so we can get this chapter done before Labor Day. If you have any questions, please don't hesitate to ask.